Hello, I'm Vinita.
Hello, I'm Suman. Today we have with us Hammed, who is currently working as a postdoctoral fellow in the University of Glasgow with Dr. Kagan. Hamid was born in Nigeria, and to follow his passion, he traveled to University of Liverpool, where he did his PhD at Dr. Bennett's lab.
He has done phenomenal research during his PhD, and you can find a link to some of his very popular embryo microscopy videos in the description box below. His interests include cell biology, cancer biology, personal and personalized medicine. He is passionate about his work and he is an amazing science communicator. We are extremely honored to have you with us today, Hamid. Hamid, we would request you to give a short presentation of the science you do.
Thank
Over
you
to
so
you,
much for the
Hamid.
invitation. Right. Thank you so much. Thank you so much for that. I really appreciate that. And that's really kind of you for the invitation, honestly. So I'm really honored to be part of this. So I am going to share my screen now. Good. So let's go to the slideshow. Very good. Right. So thank you again for the invitation. I really appreciate this and I look forward to the future of this type of interview and I really look forward to other people that you're going to interview in the future as well and looking forward to learn from you guys as well. So my name is Ahmed. So I'm currently a postdoc in Kagan's lab at the University of Glasgow. So most of the things I'm going to tell you today are from University of Liverpool and also some of them in University of Glasgow right now. So I'm really a Drosophila fanatic. I really enjoy working with flies. So and because flies they're really fantastic and they're really cool to work with, and also because they've got a lot of things similar to us, and also like we've got a lot of conservation with them as well as human. So we can learn a lot from working with flies. So the big question that I'm really trying to answer over the years and also in future is how do cells acquire the ability to migrate, and why do cancer cells continue to proliferate and then break the membrane of the epithelium and then migrate to distant sites while interacting with cells in the microenvironment? And also, how can we treat this type of cancer? Because as we all know, about 80% of cancer death is from metastasis. So how can we treat this type of metastasis, and can we really understand how cell acquire this type of property? So scientists are really because it's difficult to study these things in human themselves. So we tend to use model to study these things. And one model that scientists have used is the C. elegans. So C. elegans tend to break the basement membrane by a form of migration. Also, amoeba tends to migrate towards chemoattractant in the particular environment. So scientists have used this to understand how cells migrate. Also, we can model cancer cell metastasis in zebrafish. And my favorite model is Drosophila, especially Drosophila egg, where cell can migrate from the anterior part of the egg to the posterior end. And also, we can model whole organism cancer in Drosophila. So I'm going to allude to that at the end of the talk. So these are things that we've used in the past, and my PhD research really focused on the Drosophila egg. And the Drosophila egg is part of the ovaries in fly, and in flies we've got two ovaries. So the ovaries are made up of strand of ovariole. So and this strand of ovariole is from stage 1 or the germarium to stage 14 of the egg. And it is of interest that we can image all these processes. So we can image from the germarium cells which are really encapsulated by the somatic cell. So the germ cells here are in white and gray, and the somatic cells are in green. And these will form the barrier between this internal structure, the germarium, and the environment. And people have really used this model to study stem cell research, including the germarium, and also cell proliferation and differentiation. So how the cells in the stem cell in the germanium differentiate into somatic cell. There are different types of somatic cell. Some of them migrate, some of them don't. How they acquire this property? How did they differentiate into this family of cells? And also, we've used this model to study cell migration and cell polarity and the ability to form the epithelium. So the somatic cell really form this epithelium around the germ cell, and any abnormality in the structure leads to loss of egg development and failure of offspring to be produced. So this model is really fantastic and really fabulous because it can allow us to understand simple genes that are required for this type of process. And not only understand genes that are required for development, but also genes that are required in disease, including cancer. And I've mentioned earlier that we've got a lot of conservation in genes that are required for disease and development in both human and Drosophila. So we can easily extrapolate our studies from Drosophila to human. And not only can we study these Drosophila egg in fixed sample, but also we can image them over time. So we can begin to look at what are the genes that are required. Looking at this stage 5 egg, you can see it rotating. So what are the genes that are required for this rotation? What does this rotation mean? And also looking at stage 10 egg development, you can begin to look at cells that are migrating from the anterior end of the egg to the border of what we call the oocyte. And you can begin to understand what are the genes that are required for this process. And not only that, you can begin to understand how can we remove the genes, or what genes do we need to remove to block this type of migration, because this type of migration is really akin to tumor metastasis or ability of cancer cell to migrate. So also we can also study embryonic development, because at the stage 11 to stage 14 of these egg develop and they form a form of an antenna, and this antenna even that is required for development to adult in flies. So we can begin to look at what are the genes that are required for this development. Can we perturb this process? And if we perturb it, what's going to happen? So these are the things that we can study in this simple Drosophila egg. And they're really beautiful to image. That's another bread and butter in this research area. So I've really looked at this process over the years, and we've published some paper about these, and also we're also thinking of publishing some new paper about this process as well. And also we're thinking of publishing some resource paper for the community as well, to really look at the process of imaging this type of model, and also what type of microscope do you need to image them. So these are the things that we're looking at in future and trying to publish as soon as possible as well. And this is going to be available for the public soon. So presently, I'm looking. So in the past, I've looked at disease and development. So presently, I'm really looking at how can we drug disease, looking at the biology of disease and also the biology of therapeutics. So how can we treat this disease? And we're looking at treating cancer, hopefully. So, and we're taking an approach in the lab, in the Kenyan lab now in Glasgow. So we're taking an approach of either evolution chemistry or also personalized medicine. So we're taking an approach from chemistry and medicine to really bring in compounds that can be used to treat cancer. And which then bring me back to the beginning that, okay, cell invade or break the epithelium and migrate to distant sites. So can we develop a model that can model these in flies, and also can we treat these flies? And not only treating them with a particular inhibitor of kinases or phosphatases, but also can we treat them can we look at cancer immunology and also treat this with antibodies? And this brings us to the tumor microenvironment, because cancer doesn't just migrate on their own, they also interact with the tumor microenvironment. So in the Kenyan lab, the approach we're taking is we sequence patient's tumor, and then we develop a personalized cancer avatar for them, or Drosophila avatar, and then we do a lot of drug screening. So we can do as much as 300 drug screening, and also we can recommend this to patients. And not only that, we can also do a bit of chemical evolution. So these traits recommendation is really for approved drugs, and we all know that for drugs to be approved, that really takes a long time. So assuming we're starting from a drug that is not yet approved, that's going to take longer. So what we can do is we can evolve these compounds. So what we can do is we can screen for these drugs in the avatar, and then we can play around with the compound, with the structure of the compound, and develop a better compound than probably approved drugs actually, and then that can be taken to clinical trials. So these are things that we're presently doing in the lab at Means, and really what my research is really focused on. And also we're developing other technology in the lab that's going to become clear in future, and that's also going to help us in better drugging cancer as a disease. So I'm going to leave the community or the young folks like myself with a bit of advice that, don't be afraid to try new things and try and move out of your comfort zone, because we always want to be there. But for us to really do something different, we really need to move out of it. And if you've got a new idea or something that you really want to do, find the right people that can help you. And if you find the right people, you're going to succeed at it, because probably they're better than you and they can help you get to where you want to. Because everything always seems like it's impossible until you do them. So thank you so much for listening, and I really thank my PhD advisor, Dr. Hammed Badmos, and also currently my postdoc advisor, Dr. Professor Ross Kagan. So for the opportunity to always do the research that I love, and thank you guys for inviting me to give this short presentation as well. So thank you.
Thank you so much, Hammed. This was an excellent presentation. I really enjoyed it. We really enjoyed this.
Great talk. And now we would like to start with the question answer session. So we are excited. And
good.
So our first question is, hello. Yeah, our first question is, when did you start falling in love with science?
Right. So that's a very good question, and yeah, it's really fantastic to really fall in love with science. But I was lucky because like my mom is a pharmacist, and I've always wondered that, okay, she gives this medication to someone and then they're gonna get better, and I've always like, oh, what was really going on? How are they getting better from these things?
Right.
And that really allows me to really go into science and be like, oh, for me to do this, I really need to research into drugs or research into the system. Like, so I did biochemistry, and that allows you to really understand metabolism, understand the system in the body. So that really leads me towards that, and just searching for that type of answer really allows me to develop my skills as an undergrad and also in my postgrad years as well. So I've really been lucky, I would say.
Wonderful. So our next question. So we all have certain when we are growing up, there are often certain instances or incidents that happen in our life which make us realize that this was there in us, like that. So on that regard, was there any particular incident that you can remember which made you realize your inclination towards science? Like it could be a experiment that you did as a child, or in your school days, or something which you created. It could be anything. So
that's really fantastic, and so that's a very good question, and that's related to the first actually. So I think myself was really the reason for falling in love with science. So I'm going to tell you a bit of a story. So there was a saga when I was young that anytime I go for football, so I don't play football, and that has been part of me for a while now. So the reason for that was because anytime I go out to play for football, I live in a part of the country that is about 25 to 28 degrees all year round. So anytime that I play football, I come home feeling feverish. So, and then my mom is gonna be like, take paracetamol, you'll be fine. So, and then after taking the paracetamol, I'm up and running again. And I feel like my body is really the incubation, is really the incubation for myself, that I was like, what's really going on with me? Why is it that I have to take paracetamol to feel better? Why is it that when I play football, I feel feverish? So what's really going on with my system? So trying to figure out the answer to that really inclined me towards anything medication, anything pharmacy, anything medicine, anything science. So really, that was really my turning point to what is really the problem in my system, what's really paracetamol doing to me. So trying to figure out the answers to these really inclined me towards science, I would say. So, and that's really fabulous
cool.
question.
Yeah, that's pretty cool.
So,
Thank you.
So what do you think is the most important thing that a scientist should have, like a to-be scientist should have?
Yeah, that's a very difficult question, and I would say I would say that anyone can be a scientist, honestly. So anyone can be a scientist. So there isn't all mark for scientists. But one thing that I would say is anything that you chose to do, anything that you want to do, and anything that you're ready to do, make sure that you love and you're passionate about it. So because once you love it and you're passionate about it, it doesn't look like a job to you. It's just really fun. And then over time you're gonna enjoy it. So I would say that would be my answer to what are the features of being a good scientist is really love and passion for it. And I hope we can continue to live in a world that people that will be recognized and people will be appreciated for that. So I would say, love and passion for what you want to do. Yeah.
Right. Absolutely. So
with
that, we come to the next question, which is, what do you think, according to you, is the biggest myth that exists in the scientific community? Like, if there is any.
Yeah, that is a very cool question, actually. So the thing is actually not just the scientific community, but also the society as large. So I believe, so as growing up, so the society believes that scientists, you're lone genius, you're the one just waking up in your lab doing this, doing that. But actually, science is a community stuff, is a collaborative thing. So it is not just for one person to do. So that's one thing that I believe the thinking is going to change over time. That no, you cannot do science on your own. You cannot be successful on your own. You need people to support, to guide, and to really collaborate or contribute to what you're trying to do. And then that is really the definition of success. And that is really what should change in the community as well. So I think science is not just a one person thing or a collaborative thing.
Absolutely. I totally agree to that. And the more we collaborate, the more we learn and the more we expand. Yeah.
Yeah. So as a PhD student, everybody face different challenges. So in your PhD, what was the biggest challenge that you have faced?
Oh, yeah, thank you for that question. Absolutely, that's right. PhD can be difficult, but the main challenge for us while doing my PhD was funding, really. So finding the right people that's going to pay the money for us to do what we want to do, and that was a bit difficult. So, but over time we got over. And the thing that I was lucky to have doing my PhD was really the right mentorship. So I've got my supervisor, Daymark, he's really nice. So he's a very good person, and to have him. And now, as a postdoc, I've also got my boss Ross, and he's also a really fabulous person. So I've been lucky to have the right people guide me over the years, and also the right environment as well. And that really matters. So really, as young people, we should try and find people that will really boost the success in us, or really the strength in us, and then that can really help us be successful and be who we really want to do, what we really want to be, or really do what we really enjoy. So I think funding is a problem, but the right environment really helps.
Yeah, that's right. I totally agree to that, because in PhD mentorship is getting the right mentor is something which is,
Exactly.
I mean, your luck has to be good for that. Yeah. So from that, we come to the next question is how did you deal with your failures during your PhD? I think that's something which from where we can gain a lot of lessons. So if you would
Okay, yeah. So failure in science is inevitable. So that's one thing. And I struggled to compromise with that in the past, but I've learned my lesson now. So and I would say as young people, the earlier we learn the lesson, the better because we're gonna fail. That's one thing. And someone once said that, if you don't fail, it means that you've not tried something new. So if you fail, it's really part of learning and part of the knowledge. So what I do is, and also, and another thing that the beauty of science is that some things are going to work for you. So my coping mechanism is that I capitalize on what works for me and then learn from the failures. So I don't really pay too much attention to the failures, but really learn from them and really capitalize on the success. And that's gonna say people are gonna perceive that, or even you're gonna perceive that as if you're succeeding always, but it's really you're just learning from the failures. So I would say that's the best way to do it. Failure are gonna happen, but try and learn from them rather than capitalize on them, but really capitalize on the success. Yeah.
that's absolutely. Thank you. Thank you.
Right.
So,
Thank you so much.
like, since I have been around a lot of PhD students, so they all say that PhD changes you in a lot of ways. So, what do you
Yeah.
think? Like, how have PhD changed you? How have it added or subtracted things from your personality?
Wow. Yeah, that's a very good question and and really, really, really cool question actually. So as a teenager, so I started uni at the age of 16. So I was so at the age of 14, 15, 16, I was a bit arrogant because I was like, oh, I knew everything. I thought I'm the best in everything. But actually it is not. Actually, I realized that. So I was shocked when I got into university and realized that there are people that are far better than me. And also like in uni doing PhD as well, there was so many people that are far better than me. So really that was really a turning point for me that I've learned over the years, and as an undergrad, also as a PhD student, that I've really developed these humility skills and also my humble personality to really make sure that I'm really very humble and really learn from people rather than just being arrogant. And that's really changed me a lot. And I've also devoted myself towards helping others. The little I know, I tend to really pass the knowledge across. So these are the things. So PhD and even like learning over the years has really helped me boost my personality from, I would say, from the wrong side to the right side, really. So because if you're intelligent, then you shouldn't be arrogant. So it is only people that are not intelligent that are arrogant, really. So I would say that has really changed
That is well said. That is well said. Thank you.
my right. Thank you.
So yeah, I mean that's if you want to learn, when if you're arrogant, that's it. That's where you stagnate, right? So
Exactly. Yeah. Yeah. It
yeah,
doesn't take you anywhere.
and I think you can learn from everyone. Like
Yeah.
it doesn't matter the age or anything, status or
Yeah.
that's
Correct.
so that's so our next question. It's a little bit of an insight into like the uh, PhD world and the academic world rather. Hammed, have you ever faced any discrimination during your academic journey? Uh,
Right, that's a very good question. Luckily, I have not. So I've not faced any form of discrimination. And honestly, that really happens. And I've had stories from people that happens a lot. So but I am looking forward to a world or to very soon that something like that is not going to exist and it's going to be outdated. And people will realize that you don't need to really discriminate. You really need to accept people for who they are and really
right.
embrace people for who they are. So I hope that won't be a thing in future, honestly.
Exactly.
Right.
Yeah. So, like we all meet mentors who sometimes they are good, and like I don't think mentors are really bad, but yes, like sometimes they teach us a lot more than just work. And like so what makes you a good mentor? Like, since when you were doing your PhD, you must have supervised a lot of uh, desertees and trainees. How was your experience, and what do you think what makes a mentor good?
Hmm. Actually, that was really a very good question. And my principle is that so what is good is obvious and what is bad is obvious. So you know that oh, when you're doing good, you know you're doing good. And when you're doing bad, you know you're doing bad. Although some people don't realize that. So, but to me, I think a mentor should be dynamic. So you should be a dynamic mentor that you can understand the diversity of your mentees. So the individuality of mentees differs, so that every mentee is different from one another. So you should be able to understand that and really have a coping mechanism to deal with them. So I would say a mentor should be very dynamic. So that would be my spot on features for feature for a mentor. Yeah.
That's a really good thing. Like the point you mentioned about to understand, you can bring out the best in them.
Yeah,
Right?
I agree. That's correct.
Yeah,
That's
yeah.
correct.
I think with that, we will go to our final round of this session, which is a rapid fire round.
Yeah,
And
and you have to be as quick as possible.
so, Hamid, we'll start. I'll start with the first question. One book which is a must read according to you.
Yeah, it is rapid fire, so I'm not going to take too much time. So I would say like you should read First and Fly. So I'm just a fly person.
Oh,
So and I'm a
this
bit
is
biased
this
here.
is
So
an
I would say read
amazing
First
book.
and Fly. So it's you're gonna really enjoy it and you're gonna really learn from it. And also it's not just for researchers but also for the society. So give it to your families, let them read it. It's really spot on and it's really nice. So Stephanie Moore really did a nice job there. So I would say read that.
So when I went for my dissertation, day one, my mentor gave me this book, and it's amazing. It's amazing.
It's very nice. It's very nice.
Yeah. So I'll go to the second question. What would you have done if not a PhD?
Oh, very good. Actually, during lockdown, I discovered that I'm a very good cook. Like really, I really enjoy my cooking myself. So, and I'm very sure other people that have eaten also really enjoyed it.
That's
So
wonderful.
I would say probably I think I would have opened a restaurant if
Wow.
I if I'm not inside. So that would be my go to backup plan. So, but still in my mind though. But yeah, I would say I would do that. Yeah.
That's wonderful. So, Hamid, who
Uh,
is your favorite scientist?
very good. Actually, I've got a lot of scientists that I really admire, and I can start naming that. Oh, Albert Einstein, or other people. So, but really, I really believe in scientists that you can see and you've talked to, and really, those are people that really catch me and really catch me really very well, and really people that I really look up to. So I would say I've got several people, including my postdoc supervisor. So Ross Kagan is one of my favorite scientists. Dennis Montel, she's in Santa Barbara. She's also one of my favorite scientists. Sonia Rocha in Liverpool, one of my favorite scientists, and Mark Pfeiffer at UNC Chapel Hill, also one of my favorite scientists. So I've got several people that I really look up to. So yeah, so I really like what they're doing, and also their approach to students, or also their approach to science, and also to people in general. So that really allows me to really look up to them. Yeah.
So coming to the next question, which according to you is the most revolutionary paper you have ever read, like revolutionary research paper?
Very good. So I would be a bit biased here, and because I'm a Drosophila person, and really, what really revolutionary, sorry, what is really revolutionary about a paper is really the contribution to the field, right? So, and in my field, the borders and migration field, So a paper from Dennis Montal et al. 1992 was really something that really opened a new field for people to really interrogate the system. So I would say that is something that is revolutionary for me in the field. So that is something that you should read if you really want to understand the system or really begin to tackle the question from the system. So that's something that is really, really cool for me.
Oh, it's amazing. So, Hamid, what do you love to do most when you're taking a break science and research?
Yeah, very good. Science is fun, yeah. So, but yeah, we need to enjoy the outside science world as well. So yeah, so I enjoy going cycling. So I play a lot of table tennis, and also if I've got the time, I also enjoy dancing. So these are the things that I love to do. You know, when
That's
not
pretty
when
cool.
I'm not playing with my flies in the lab. But yeah, most of the time I play with flies, but outside that I can do all those things as well.
With this, we
That's
are
amazing.
coming to an end of this interview. I I hope you have enjoyed it as we have enjoyed it a lot. Yeah, and thank you
Right.
so much
Thank you
for
so much,
encouraging us.
guys.
Thank you so much. Thank you so much for sharing
Thank you
your
so much,
journey and
guys.
your